All right, welcome back, everybody. In this lecture, we're going to be continuing down the path that we started carving out in the previous one when we started talking about the basic principles of memory. Just to review and provide some more context, if you recall back to our last lecture, we spent a lot of time looking at where memory research started, some of the different ways we can test memory, and then we spent a considerable amount of time at the end of that lecture focusing our attention on different components and aspects to memory that we could understand in order to, well, get to what we're looking at today, and that's application-based research on memory. Now, as I mentioned in the previous lecture, what we're going to be focusing on when looking at application-based memory research in this class is not necessarily cutting-edge new stuff that you could potentially study under a specific researcher, but more applicable stuff that has been tried and true in terms of being verified in research and stuff that really does have its utility and has led to other current groundbreaking research on the topic of memory. So let's get started and look at some of the things we understand about memory after we established some of those tools that we've been discussing. Now, to explore some of the topics that we're going to be looking at today, I thought we'd start off with some little activities that tend to be a lot easier to do when the class is in person, because then I can have you sitting down with your notebooks in front of you, comparing and contrasting your responses to the class, and sort of getting a sense of the aggregate performance of everybody on some of the things that we're going to be looking at. Since we don't really have that option at our disposal right now, what we're going to do instead is try to sort of replicate what we would do in person and postulate, even though there's going to be individual differences in performance, what the group probably as a whole in this class performed like, and talk about how those performances relate to some of the concepts and terms that memory researchers have discovered. But as we get into this, I do always have to warn you that, as we mentioned in our last class, memory research is a very complex thing, and you might not behave in accordance to what we're expecting you to do in these types of activities, simply because there are individual differences and things that can tweak the way you yourself react to the specific stimuli you're encountering. But I want to promise, even if you're not necessarily aligning with what I'm mentioning, if we were sitting in a 200-300 person class and I was taking a tally of who was experiencing what, a lot of the effects that we're talking about would be visible. They'd definitely be something that we could see in those large numbers of people. So without further ado, let's try 3 different activities. In the first activity, all I want you to do is listen to a list of words that I'm going to read. And after I'm done reading the list of words, not until after I'm done reading the list of words, try to write down as many as you can still remember. These will be words, not nonsense syllables. And again, you can't just write down a list of words as I'm reading them. You have to wait until I've finished and then write down as many as you can. I know that might seem like I'm kind of talking about something weird, but we always have 1 or 2 students that accidentally write down the list as I'm reading it, and in that case, we're not really testing your memory, we're just testing how quickly you can write stuff down. So let's hold off on the writing until after I'm done reading the list, but once I've finished for this first one, there's nothing else you need to do. Just write down as much as you can still retain, and we'll talk about some of the effects that we see relating to this on the next slide. Let's get started though. Ring, shoe, time, ear, bike, bed, corn, lace, table, rock, dog, rack. Please write as many down as you can if you're participating in this. Pause me if you're not quite done yet. We're going to continue on because it's weird to have an awkward silence over the radio. Over the video, I guess. Now what we're going to do is another activity that requires a little bit more complexity to it. So I'm again going to read you a list of words, and I want you to try to retain as much as you can while I'm reading it, and write down everything you can still retain after I'm done reading the list. But while I'm reading the list, and actually a little bit before I start reading this list, what I'd like you to do is think of a name or some word that you can repeat in your head over and over and over again as you're listening to the list. In most classes, I typically ask people to think of the name of their best friend that has a very simple name. So Bob Smith is much better than, George Stephanopoulos, or something that requires kind of lots of syllables and complexity in it. So if you have a friend that's got, say, a 2-3 syllable name, that's great. You could use that, or again, if there's a specific word that you want to say in your head over and over again, go for it. But as I'm reading the list, if you have that thing that you can repeat over and over again while you're listening, we might produce a different effect that we'll talk about again in the next slide. So let's get ourselves centered. Pick our word or name. And I want you to start saying that word or name right now. And I'll start reading the list here in a few seconds after you've been doing that for a while. Remember, keep saying it over and over in your head. Plane, cat, broom, car, mouse, brush, truck, bear, mop, train, ant, rag. All right. You can stop saying the name in your head now, or the word in your head, and try to write down as many words from that list as you can recall. Again, feel free to pause me if you still aren't finished with the list. I'm guessing most of you do need to pause me. And when we're back here, what we're going to do is one last activity. It does require a little bit more work on your part, but I'm confident you can do this. What we're going to do is play something that cognitive psychologists call the game of sevens, or the rule of sevens. I'm going to read you a list. Don't want you to distract yourself while I'm reading the list, but after we're done, I'm going to give you 2 numbers. And what I want you to do is count backwards by sevens from the first number to the second. So say, for example, I gave you the numbers 21 and 0. You would say 21, 14, 7, 0. And when you get to that second number, you can then write down whatever you still have remaining in your head. So again, list 2 numbers, you count backwards by sevens from the first number to the second. If I'm doing my math correctly, you should be able to land directly on that second. If you don't, and you get below the second number, just start writing as many words as you can remember. But really try to do this activity, the rule of sevens. It's meant to be something that makes you think a little bit and spend an extra second on it. And hopefully, if the effects work like I'm expecting, we'll be able to talk about how this rule of sevens impacted you again on the next slide. So here we go. Get yourself settled. I'll start reading the list in just a second. Heart, shout, time, blank, belt, flash, stain, tree, stand, stamp, board, book. 52:17. Remember, you should be counting backwards by sevens from 52 to 17. I'm guessing most of you are at 17 now. If you're not, it's probably been enough time and enough work for you to try to write down as many words as you can still remember. When you're done with that, head on over to the next slide and we'll talk about what these tasks have to do with memory and some of the effects that we're guessing we encountered here in this class. So what most of these tasks are trying to highlight is this really interesting effect that we call the serial order, or sometimes you'll see it listed in other books as a serial position effect. It's this weird discovery that when we're, say, read a list of words, or we watch a movie, or hear a story, or we get something in some sequential order, not all that information that we're presented has an equal chance of staying in our heads. Instead, what we tend to see is the stuff at the beginning of those movies or stories or lists, and the stuff at the end of those movies or stories or lists tend to stick with us a lot longer. If we're looking at long-term effects, it's usually the stuff at the beginning that seems to really persist in our heads for a long period of time. And that's where I want to start our focus right now, that stuff at the beginning, because that gets a special name, something that we'll be revisiting actually later on when we get to social psychology as well. It's this thing that we call the primacy effect. In essence, what we see is that when you read a list of words or you watch a movie, again, the stuff at the beginning of those things tends to stick in your head much better than things that are in the middle. And my guess is, in that first activity, we probably created the primacy effect. If you look at the very first list that you came up with, if you were participating, that is, my guess is that you probably have the words ring and shoe written down on your list, the very first two words from that original list. I'm guessing when we get stuff in the middle, like corn and lace, you probably don't have those words on the list as often. Now again, there's going to be individual differences. Some of you might be staring at the words corn and lace right in front of you and maybe don't have ring or shoe in there. But as an aggregate, we tend to see that this primacy effect, when there's no distractions, no problems, tends to be very strong. However, if there are distractions, like we did in that second activity, where you were saying the name of your friend over and over again, especially if you're not as focused as maybe you were when you were doing this task, this primacy effect can be obliterated. So we probably, if we were in class, would have seen around 90 to 95% of the class saying that they remembered the word ring, and 90 to 95% saying they remembered the word shoe from the first list. But on that second list, with the distraction of you saying that word over and over again, we usually see a drop down to about 60-70% of the class saying they heard the first word of plane and cat. Essentially, or the first words of plane and cat. Essentially, what's happening here is that added boost, that benefit of the primacy effect is removed. It doesn't make it impossible to remember that stuff at the beginning. It just kind of puts it on the equal weight of the stuff that's located in the middle. This is also true of the recency effect, where, as the name kind of implies, it's the most recent stuff that we can keep in our heads for at least a short period of time. If we go back to that first list, I'm guessing most of you recalled the words dog and rack, the last two words on the very first list. Usually, if this is typical of most of our classes, 90 to 95% of the class will indicate that they remembered the words dog and rack. But if we go to the third list, where we had to do that game of sevens, or sometimes, again, it's called the rule of sevens, I would surmise that we would see considerably fewer individuals remembering words at the end of that list, the last two words being board and book. Now, again, some of you might not be conforming to this. There's a decent chunk of the percentage that do still remember these words, even with those distractors. But nonetheless, the effect drops. And that's what the serial order effect really tries to explain. It's not that we can't remember stuff in the middle of stories. It's just that we do have this innate ability to remember stuff at the beginning of stories and the end of stories much better than the stuff in the middle. However, there's constraints on us, like distractions at the end or distractions at the beginning. These effects can all but be eliminated. And understanding these basic effects is something that I want you to get from this, but also we're going to look at some applications of this a little bit later. So I want you to keep this in your pocket as we move on through the material. Now, to explore another interesting memory effect, or actually pair of effects, what we're going to do is a new set of activities that are going to be a little bit more complex than the first ones that we've been doing. These require not just one set of instructions per activity, but actually two sets of instructions. So I am going to give you the first bit of instructions right off the bat for the first activity, which is I like to call the fruits activity. You'll understand why as we're progressing. And then I'll get to you the second set of instructions after we do something. So I'm going to read you a list of, as you've probably guessed, fruits. And after you're done hearing the list of fruits and trying to remember it just like you did in the previous activities, don't write anything down. Just wait for me to give you a set of instructions, or second set of instructions. We can kind of go from there off that second set of instructions, but it's really important that you keep in mind that you're not writing anything down until we're through with the entirety of this first activity. So let's get ourselves situated, ourselves ready. And I'll start reading the list in just a second here. Apple, pear, blackberry, apricot, plum, pomegranate, lime, grape, blueberry, peach. And again, do not write down this list. Instead, what I'm going to do is read you another list. And I want you to listen to this extra list, the second list, just as closely as you did to the first one. After I'm done, I will give you a third set of instructions, and I want you to make sure that you don't write anything down until you listen to that third set of instructions. So here we go. Strawberry, banana, orange, pineapple, cherry, mango, lemon, cranberry, kiwi, papaya. What I'd like you to do is try to remember as many words from the first list as you can. Write them down. Only the first list, though. Please pause me if you're still writing. If you're done, what we're going to do is move on to another activity. I promise we'll explore the effects of the first one in a little while. We're going to move on to a second activity here before we explore those effects. And this one is what I like to call the flowers activity. You can probably guess already what the theme of this activity is going to be. So I'm going to read you a list, just like I did last time. And then I'm going to give you another set of instructions. And please make sure you don't do anything until you hear that second set of instructions. All right, here we go. Daisy, carnation, geranium, marigold, orchid, pansy, violet, poinsettia, sunflower, honeysuckle. All right, that's the first part of this. Now what I'm going to do is read you, as you might have already guessed, another list of words. I want you to, just like you've been instructed every time so far, do your best to try to remember everything within this list. Afterwards, you're going to get another set of instructions that are going to just move us forward. But please, do your best to write everything down. To listen to everything, not write everything down. To listen to everything that I'm saying and try to retain everything that I'm saying as we go through this. So here we go. Here's that second list. Tulip, daffodil, iris, hibiscus, rose, lotus, water lily, lavender, goldenrod, mistletoe. Now, what I'd like you to do in this one is write down everything from the second list, not the first list. Again, pause me if you need, but we're going to progress on to what effects relate to what we just did here. So, what we're looking at with these weird, odd activities with the special instructions are ways to bring out a really interesting effect that was discovered by cognitive psychologists called the interference effect. It surmises that if we have competing information that overlaps that we're being presented, that competing information, even though it might be related, can actually be more challenging to retain than if we just had encountered kind of one discrete bit of information on its own. The first type of thing that can happen is that it's really tough to retain new information, things that we're encountering, if we say have something from our past that overlapped with that new information. That's sort of what we did with the second activity with the flowers, where I read you a list, you spent some time trying to keep that in your head, and then I read you a second list that you were really going to be tested on later on, even though you didn't know that at the time. My guess is because there was that competing information, most of us didn't get to remember all of the different flowers from that second list. And my guess is that also a number of you probably wrote some words down that you weren't supposed to. So this was the list that you were supposed to write down, just in case you want to know. Tulip, daffodil, iris, hibiscus, rose, lotus, water lily, lavender, goldenrod, and mistletoe. Yeah, my guess is that the vast majority of the class, unless this is a very atypical class, had a couple words from the other lists that found their way into their lists. And again, people oftentimes don't get all of those words, even though it should be easy to remember a decent number of them since there was an obvious theme to them. That's what proactive interference is all about. There's lots of real-world examples of this happening as well, not just in labs with weird instructions relating to lists. One of my favorite examples of this is something that, well, we're not really encountering in this online format, but you'll eventually encounter if you get to meet students at some point in life here moving forward. And it's a situation where freshmen coming into many colleges or first-year students coming into many colleges have this adept ability at learning the names of numerous people within a short period of time. They, get to learn the names of 20 or 30 people that live in their dorms. They get to learn all of their classmates' names. They have their schedule memorized, their instructors' names memorized. And they're just really good at doing this in their very first semester. And then the second semester, things start to get a little bit more challenging, where remembering their schedule becomes a little bit more difficult, remembering who their teachers are becomes a little bit more difficult, remembering the names of new people you meet becomes more challenging, and this gets progressively more and more difficult as each successive semester passes. That's what proactive interference is all about. It's this kind of extra weight, this challenge that comes when we're introduced to information that's not the same as previous information, but there's a decent amount of overlap from that previous information. And it eventually leads to seniors sometimes not remembering during finals week, what their class schedule was, even though they've been in class for 16, 17 weeks. Not necessarily because they're not trying, it's just this proactive interference thing can be pretty darn powerful. Even though if you are a senior listening to this, I would suggest just committing a little bit more energy and time and making sure that you don't kind of miss your class throughout the entire senior year because of it. It's not that it's impossible to retain this stuff. It just is significantly harder, to be fair, to remember that new stuff if we have old competing information. And it's not that that old competing information is kind of able to avoid this interference effect. Just like we had the primacy effect and the recency effect, we've got proactive interference, and we've got the other end, which is what we call retroactive interference, where we tend to really struggle to retain old stuff if new competing information comes into our minds. So if you want to test your memory on the fruits activities that we did, this was the list that you were supposed to write down. Apple, pear, blackberry, apricot, plum, pomegranate, lime, grape, blueberry, peach. My guess is that a huge chunk of the class probably lost a couple of those items. And more importantly, I'm guessing that a large number of you wrote down words that you weren't supposed to write down. I usually see lots of mangoes and bananas and pineapples on that list, even though those were a part of the second list that you were supposed to sort of ignore. And again, this is not just something we find in the lab. We see this in real life all the time. One of my favorite examples of this is when people get to a new place that has, say, a sequence of numbers that they have to memorize. The classic one is if you, say, have to remember a new lock combination when you arrive at a new school or a new gym. More often than not, we can retain that new lock code fairly fast. But what it does sometimes do, in a way that we don't even really identify at the time, is it makes remembering some of those old lock combinations significantly harder. So if you were, say, going to a gym right now on a regular basis, you might have been kind of programming yourself into remembering a specific lock code and might not have realized that maybe even though you had a high school class that you were taking or a high school lock that you were using for 4 years, you might be surprised to find that you don't remember the combination to that lock anymore. Or it could relate to things like where you parked your car last before your most recent parking job, so 2 times ago. Right? That information just tends to disappear from our heads when new competing information is there. And it's not necessarily that these things are bad. Well, I mean, I guess it's not that they're helpful either. It's just these are things that really highlight how our brains, how our minds work when it comes to memory. And it's just kind of a unique effect that has lots of applications in different situations. Now, there's one last activity that I want us to explore, but this one's going to be significantly faster, and it should be, in all honesty, probably the easiest one that we've done. I promise it will relate to a concept that we're going to look at. I don't want to give away too much, just as I haven't given away too much in our previous ones. So I'm not going to explain the effects that we're going to look at. And so just give you some instructions. And if you can, and you're willing, I'd love for you to just try to follow along, and we'll see if some of the effects that we find are indicative of what researchers have found with respect to this effect, or this topic. So I'm going to read you a list of words. And much like the very first activity we did, you don't have to do anything additional. Just listen to that list of words, and when I'm done, try to write down as many words as you can remember. This shouldn't be that challenging, and we'll explore why in a little while. But please, just do your best, and we'll see how this performance compares to the last topic that we're going to discuss with these activities. Here we go. Dream, dresser, pillow, rest, night, snooze, bed, dark, eyes, shut, sheets, purple, blanket. All right, try to write down as many as you can recall. Again, please pause me while you're doing this, and when you're done, we'll advance to the next slide. Okay. Now my guess is that if you followed along and you went through that activity, you likely found for the very first time that you were able to get over that 7 plus or minus 2 threshold that we discussed earlier. I know some of you might have already gotten there, but what we tend to see when we're in an in-person class with this is the vast majority of the class, we're talking in the 90% range again, tends to recall over 9 items with this last list. And then I usually ask the class why you were able to remember so many this time versus the other ones. And the consensus is often that it was easy because there was an obvious theme underlying all the terms that you were reading. So I ask people things like, well, what were the words that really stuck out to you? And people would say things like dream and bed. And the highlight here is that people kind of come to this very obvious conclusion that if things have a theme, if things are connected, it tends to stay in our head significantly better. And this is something that's been verified from numerous studies. Ebbinghaus himself realized that there was a lot of intuitive value to things having meaning. That's why he created those nonsense syllables, because he appreciated that there would be extra weight on things that had some type of meaning to him. So when we started to look at this idea of meaning and how connecting things made things easier, lots of early memory researchers just implied that it was advantageous to have themes and things overlapping. But then a really interesting question came up, and that was how accurate we actually are with some of those things we're being presented if, say, there's bits of information that don't fit the framework of what we're looking for, or maybe there's missing information that we suddenly put into that bit because, well, it fits better. One of the first examples that really highlighted how much we try to schematize, to kind of link things up into a coherent theme, were studies that utilized this really weird tool that was developed. It was a story called The War of the Ghosts. And in this story, people hear about these two young men from a place called Yugalak that are going on some weird hunting trip and get caught up in a war, and there's all of these kind of supernatural, odd, very disjointed things that happen in this page to page and a half story that people are read. And with the War of the Ghosts activity, what people are asked to do after they hear it is try to retell it to somebody else. And what tends to occur every time people do this is they tend to omit certain facts that just don't really fit a good story. They tend to add things that make things a little bit smoother in transition. And in the end, they create this story that has some resemblance to the original one, but has lots of things that are kind of different, unique from the original story that they had been presented. And this is something that we call the reconstruction effect. And we see it in lots of places. In fact, this last activity that we did might have produced the reconstruction effect for many of you. I'm guessing most of you did remember the word dream. Most of you probably remembered the word dark. I'm also guessing a large number of you remembered the word sleep, which just so happens to not have been a word on the list. Typically, in a classroom setting, we usually see around 70 to 80% of the class insisting that they heard the word sleep. It's a little bit easier to prove that I didn't say sleep this time by just having you go back to the last slide and listening to the last little bit where I read the list, and you'll find I did not ever say the word sleep. Many of you are struggling probably to accept that, right? Your brain just refuses to see that was embedded in your own head by maybe some internal monologue you have. What most research also suggests is that even though purple was one of the last words I read, because it wasn't really related to everything else, usually people are much less inclined to remember that random unassociated word than all of the other words that were read on the list. And all of this, again, highlights the impact that our mind can have on what we're encountering, and it creates this really odd reconstruction effect. Now, if we're looking at other real-life examples of this, what we tend to see and contend is that this is something that's going on all the time. If you've ever had a fight with your roommate about what it was that happened the previous night, or who said what and went where, you can feel comforted in the fact that both you and your roommate, according to reconstruction effect research, are probably both wrong. You both had your own interpretations, your own things that you added and omitted to kind of come up with your narrative. And it wasn't intentional that you did that, but this is the kind of effect that we see repeatedly. It's also something that's been explored in kind of more extreme and other scenarios. There was a researcher who spent a large portion of her career talking about sort of the malleability of memories of children and how we can, through specific types of prompts and questions, get individuals to remember things in ways that never happened. And her work suggested that this can happen for adults, but it's especially prominent in kids. And it can get to a point actually where if we're given the right prompts and the right suggestions, we can misremember things from our childhood just by the mere suggestion of a researcher that something happened, or that we should see something in a specific light. It's not that we can't be moved as adults. It's just Loftus really highlighted how much more malleable and dangerous it is, this reconstruction effect, when we look at young kids and even adolescents. It's not until usually we get into adulthood where we become a little bit less inclined to be impacted by this. But even as adults, we do kind of subject ourselves to little minor versions of the reconstruction effect. One of my favorites is something called the hindsight bias, where we all have this tendency to think that our logic when going into a situation was crystal clear, even if the outcome later on is slightly unexpected. You might have found yourself after a bad breakup or the dissolution, of a friendship, said something like, "I didn't like that person much anyway," or after a sporting team that you really were cheering for lost a big game, you might have said, "Well, I knew they weren't going to win in the first place." It's a very profound effect that many individuals run into. And it's tough to overcome because of how our mind is kind of programmed to come up with a narrative to explain things because of the advantages that come with it. And so now that we've spent about 30 minutes talking about all the ways that your memory has these kind of quirks, and maybe even we would call them flaws to them, let's talk about other research that's looked at things that you can do to enhance this very valuable tool of memory. I'd like to start, when we do this, by talking about the most important, prominent one that's been studied by memory researchers for years. It's something that we call the levels of processing effect. What this effect suggests is that if we want to retain large amounts of stuff, what we need to do is find ways to engage in what levels of processing researchers call deep processing. Now, there's lots of different models and ideas about what qualifies as deep processing. You might have heard in educational classes about the different ways that you can try to kind of improve your understanding of material by either memorizing it or trying to explain it or trying to assess the quality of that information. Kind of getting at different wrinkles and folds that require more and more thought and interpretation of things. This is what the levels of processing model is getting at, even if it's sometimes difficult to truly quantify what it means for somebody to engage in deep processing. But if we can have a relatively intuitive sense of what deep processing is, what we find in the levels of processing model is that those that engage in this approach when trying to understand material tend to not only retain more of it at the time they encounter it, but that information sticks with them for significantly longer. And this is, of course, in contrast to what we call shallow processing, where we really are just trying to process stuff, keep it in our heads at the surface level for just a short period of time. Now, there's probably lots of reasons as to why this effect works really well. You do have to engage in more cognitive efforts. It does take longer to engage in this deep processing. And honestly, once it's there, you got lots of ways to get at that information because of how you've related it to other things. But regardless of the key feature to it, because it is a pretty complex thing, the thing I want you to take away from this level of processing model is if you approach your classes through this technique, what most researchers found is that not only can you probably save yourself a lot of stress and problems, but you'll be able to retain a lot more information long after you're done with the class than if you just focus on rote retention of things. I know many college students have this tendency, because they've learned these skills in high school, to do things like create flashcards and just memorize 50 terms without being able to explain how those terms relate or how these things apply to different situations. Others simply just read books over and over again, hoping that eventually some of that information is going to stick. Those things can work, just they're not nearly as effective in the short run or the long run as, say, going through a book and really trying to critique it and think about things. It also, behooves you when you're sitting in class to really process what's being said instead of just frantically trying to write down everything that's on a slide. It's a skill that does require development, and again, it's a very multifaceted thing, so it's tough to pin down to just one element when talking about what deep processing entails. But if you can identify it, if you can see it, what you can appreciate from it is that usually is a very impactful thing when we talk about both short and long-term retention of information. Another kind of odd effect that we've discovered over the years is relating to something that we discussed in our previous lecture. And if you remember back to that lecture, we talked about how the process of memory really entails 3 steps. It involves what we call the encoding step, then the storage step, and the retrieval step. Well, what this memory dependence idea that we're looking at here in this slide alludes to is the notion that if we are in, say, some state of mind, or we're encountering something when we're undergoing the encoding process on information, and finding a way to recreate that state of mind or that experience or that situation when then trying to recall it tends to enhance our ability to kind of get that link figured out. The classic studies on this that first established this memory dependence idea were ones that focused on language, where they would bring bilingual individuals in, not just people that are sort of learning a second language, but people that are extremely bilingual, and they'd read them a list of words in one language, and then they would test them either in that same language or a different language. And what they found time and time again in these studies is, like you see here on the slide, that if we're tested in the same language as the one we're presented it in, regardless of which language that is, we're much better at doing that than trying to recall the translated words in another form. This might lead one to conclude that, well, obviously that works because it takes more work to translate it, even if it is second nature, so we would expect to see that effect. But this is not the only place where we see memory dependence work really panning out. Another place that we tend to see it in is what we call situation dependency, where if you are learning something in some environment, you tend to, even if that environment is completely unrelated to the information, you tend to be able to recall that information if you're in the same environment that you learned it in. So let's say as you're learning in this class and sitting there on your computer, you're sitting in one specific room every single time. Well, research would suggest if you're being asked to recall that information, you'd be better suited to be sitting in the same place where you were learning that information versus sitting in a brand new place or going to a different part of, say, your house or apartment or wherever it is that you're processing this information. This also relates to our internal states as well. Numerous studies have shown that if somebody is consuming a massive amount of caffeine while studying, they tend to recall a little bit better, or more information, I guess, when they're taking massive amounts of caffeine later versus if they don't have caffeine in their system. And if we want to go to that next step, which I know many college students do, yes, there is some research that suggests that if we do have large amounts of alcohol in our system, when we're learning something, then we tend to be able to recall that information better when we are then in that same state of mind. But when I say this, please do not consider this as an option for studying. Our processing abilities that we talked about before with depth of processing, our ability to connect stuff, our memory overall is greatly hindered when we're consuming large amounts of alcohols or any other depressants. And it's probably not a good approach. Even if you do want to take advantage of memory dependence for the class, it's probably not your best option when it comes to how to study best for this class. So hopefully from this you can, again, appreciate another little helpful tidbit that might help you move forward. And this brings me to some more specific things that aren't necessarily related to specific terms or concepts. One of the things that's often really pushed on incoming freshmen and other people that arrive at colleges for the first time is that the best way to be successful is to make sure that you are keeping up with stuff and breaking stuff up into manageable chunks. Now, you might at the time when you hear that not really understand the utility of it, because you probably come to the conclusion that, well, yes, I'm going to get the information in my head regardless of whether or not I do it a day or two before or throughout the entirety of a couple weeks. But there is memory research to suggest that that spreading out of stuff is actually very valuable. There's a couple reasons why. Some of them relates to what we've been looking at so far in this lecture. Those levels of processing ideas that we talked about are much more applicable when you have the time and the ability to really process stuff at a deep level. It's really difficult to do that on a cramming night. You might want to. You might really be kind of set on trying to link things up and understand it and apply it. But if you have a massive amount of information that you're trying to relate to, our brains are not programmed to be able to do that. Another thing that sort of can be enhanced by breaking stuff up is that primacy effect and recency effect, or what we call the serial position or serial order effect that we talked about earlier. You've got small chunks and things are broken up. You got lots of beginnings and lots of ends that tend to stick with you a little bit longer, where if you're trying to understand everything in one 8-hour session, there's just a little bit at the very beginning and then a little bit at the very end that gets to have that extra boosted effect. Now, there's other reasons as well, right? When we talk about attention and information consolidation, things that we don't get to go to in this class, but just understand that, again, there's lots of things that we've discovered in memory research, even if it's a little bit older, that has lots of applications in your everyday life. Another thing that many researchers have been intrigued by and tried to explore how we could use them in a variety of different ways are these things called mnemonic devices, little tricks of memory that help us temporarily store kind of disparate or kind of tough to retain information in ways that can actually get us past that number 7 plus or minus 2 that we talked about earlier. The classic mnemonic device or memory aid that people have looked at is taking lists and converting them into either words or acronyms or full phrases. Right? When we get into personality psychology, we'll talk about an approach to personality that tries to quantify everybody on 5 different dimensions. And when people talk about these dimensions to remember which ones we measure, they often talk about how your personality spans the ocean, or sometimes they even call it the canoe test. And what that is actually just a combination of the first letters of the 5 traits that these individuals studied: openness to experience, conscientiousness, extroversion, agreeableness, and neuroticism. Of course, this is just one example of how you could create a mnemonic device for a list of things. Again, it's more often something that's very valuable when you've got disparate stuff, and if you do it correctly, you can keep large, massive amounts of information in your head that would be tough to keep in your head if you were just trying to treat them as discrete entities. Another way you can do this is, again, to combine stuff in very elaborate ways. In fact, some of the lists that we read earlier could have been what we call chunked, combined together, and it might have allowed you to remember significantly more than you were able to remember the first time around. So for those of you that have the list in front of you, the very first list I read to you, ring, shoe, time, ear, bike, bed, corn, lace, table, rock, dog, rack, might have seemed rather disparate. But if I would have read it like this: time, table, shoe, lace, ear, ring, corn, dog, bed, rock, bike, rack, suddenly the list might have been a lot easier to tackle. I'm guessing most of you probably would have gotten all 12 words that I read there. And that's what chunking is all about. You can do it where you're combining stuff into making it a single item, or you can combine stuff into groupings, like you maybe could have done for the second list: plane, cat, broom, car, mouse, brush, truck, bear, mop, train, ant, rag. Sorry, kind of misspoke 5 times there. Anyway, if you found a way to combine those not into single words, but themes like modes of transportation, cleaning devices, and animals, suddenly retaining all 12 of those items might have been significantly easier. And these are just a few examples of mnemonic devices that people have devised over the years. Another one that's become very popular is something that cognitive psychologists call the method of loci. You might have heard of it called a couple different names. There's lots of people that have kind of claimed this idea. But in essence, the method of loci asks you to take disparate items or disparate ideas that you need to store and find a way to tether them, tie them to something you're very familiar with. The classic example is, say, if you have a list of groceries that you need to remember to buy at a store and you don't want to forget any, but for some inexplicable reason you don't decide to write it on a piece of paper or your phone, and what you can do is just close your eyes and imagine the list that you need to be paired up with something you're familiar with, say the house you grew up in or the place you're living right now. So you could, in your mind, imagine if you need bread, smearing bread all over the front door. And if you need peanut butter, imagine yourself spearing it. For some reason, the graphic imagery really helps with this one. So imagine yourself smearing it all over the couch in your house or the living room. Then you can imagine if you need milk, pouring it all over your bed, or if you want to be sadistic, your roommates or your siblings' bed. And just kind of going through those events. And then when you get to the store, all you need to do is close your eyes and just look at that front door of yours that you had in your mind and remember, oh yeah, I need bread. And walk into the living room and see the peanut butter all over the couch and remember that you need that. And if you go into your room or your brother's room or whoever's room you poured that milk on, you can remember that particular item. This type of stuff is very powerful. It doesn't necessarily help us if we're trying to remember an entire story or every detail of a class, but for the more disparate stuff, this in conjunction with some of that deep processing can have an amazing effect. And this is kind of what I want you to get from this lecture, right? That when we understand memory, there's lots of real world applications from it. And a lot of the stuff that we've been looking at here has actually led to other really interesting, amazing insights by people studying memory. And it's also led to some pretty big individual differences in terms of cognitive abilities, both for problem solving and intelligence. And that's actually what we're going to be transitioning to now, since we have been focusing a lot of our attention on this idea of memory and of the individual differences that emerge as a result of the development of certain skill sets and tools that we have. So in our next class, I will see you soon as we break down this general idea of intelligence. Until then, take care, folks.